All right, the chain rule. I think this is a very beautiful way of doing mathematics. So if we wanted to differentiate x squared plus 2 all squared, we can do that by expanding it first, can't we? So if we expand that and join these two together, we can now differentiate it. So dy by dx, put that in front, lose 1, times those two, lose that one, is that. Nice and easy. Say we wanted to differentiate y equals x cubed minus 1 all to the power of 23. We've got a bit of a, we can't expand that out, can we? So we've got to come up with another method, and I'm sure you're thinking, I bet it's the chain rule. It is indeed the chain rule. So what you do with the chain rule, and we'll just go through this very, very briefly now, and then we'll go through a much greater example later on, is for some reason we're like the letter u, so we're going to let u equal that bit there, x cubed minus 1. So now we know that y is u to the power of 23, isn't it? Y equals u to the power of 23. And we can going to create a chain. Now, you probably can't hear this, but I'm playing The Chain Gang by Sam Cooke. So I suggest that you now, at some point, you actually watch the PowerPoint from Google Classroom, and so you can actually take in the whole ambiance. So this is the chain rule. So basically, we know we've got u's and y's and x's. So this beautifully ends up with the u's cancelling, and we end up with dy by dx equals dy by dx. So dy by du is differentiating that bit, so we just differentiate that. And du by dx is when we differentiate that. So we just differentiate these two things, join them together, and we've done it. So we know there are two different notations. So if we're using the kind of function notation, so here's a similar one. We've got q of x equals x cubed minus 1 all to the power of 23. We're going to let u equal g of x. Again, it could be a q and a g, could be an f and a h, could be anything, yeah. And then we're going to say y equals f of u, which is u to the power of 23. And then we chain them together, the x, the u, and the y, if we're using the previous method, and we're chaining together the g and the x. Use that. F of g of x, so it's kind of almost a bit like the sort of one function inside of the other, yeah, with the Drago duck or whatever it was called. Let's have a look at an example. So some board work. So first off, we're going to let u equal x cubed minus 1. So now y equals u to the power of 23. So we're using dy by dx, but we remember, because we're using our u here, we're going to set this wonderful situation up where our du's will cancel. So the first thing we've got to do is differentiate the u. So du by dx, take that in front, drop a power, of course that will disappear. And we differentiate this one, dy by du, 23u to the 22. So now we've got this, and we've got this, so we can just put those together, 23u to the 22 times 3x squared. I'm just going to do a bit of joining together. 3 times 23 is 69, so I can join that together. So it's 69 x squared u to the 22. So we're kind of done, but remember that u was x cubed minus 1 from here. So instead of writing u, I can just write x cubed minus 1. So 69 x squared x cubed minus 1 all to the power of 22. So a lot easier than expanding all of that 23 times and then differentiating. So that's your chain rule. Here you do your two different notations. There we are. Which way do you prefer? So if the question doesn't tell you, you can use whatever notation you want. So here's one here with both notations on it. So really, you guys can choose which way to do it. So I suggest that you have a look at these and see the way the notation is done on both of these really, really carefully. Maybe that'd be a really good example to have in your notes, these two. But take care, because some exam questions ask you to answer in a specific way. So they do say differentiate using the chain rule, using this method. Okay, so you need to know how to do both. You can prefer one because 99% of the time you'll be able to choose which way you want to do it. Here's one with a little bit more into it than just a standard differentiate. So it's not telling you to differentiate there, is it? It's telling you to find the gradient of the tangent. So that's okay. When I say find the gradient of the tangent, that means they want me to differentiate. So you're not necessarily ever going to see this graph. I've just put this graph there because I'm a visual learner and I like to see the graph. So there's the graph. Y equals 16 over 3x squared plus 1. And there's the point 1,4. So chain rule. Let u equal 3x squared plus 1. So then y is going to be 16u to the minus 1. Okay, so I've written it in this way so it makes the differentiation. So du by dx, 3 times 2 is 6, lose a power, times that by that, which makes that a minus. And when you lose a power from that, don't forget it becomes a minus 2. Then we use our wonderful chain rule. Join these two together. 16 times 6, I think, is 96. So on the top, we've got 96x. On the bottom, we've got, if we got u to the minus 2 on the top, on the bottom, that would be u to the positive 2, so u squared. And we've gone straight back to, let's just go straight to the u. There. Now, they haven't said use the chain rule here, have they? Obviously, when you do the exercise, that's the next exercise in the book, they're all going to be chain rule questions. So you know, okay, well, I'm going to have to use the chain rule. But in the exam, they're obviously not going to tell you to use the chain rule. So you have to work out, okay, what method am I going to use to try and solve this problem? So what does it don't forget? It says find the gradient at the point 1,4. So that's when x equals 1. So the gradient at this point here is minus 6. So if we were to draw a line here, which we will do in a minute, you can see it's going to have quite a steep gradient. Well, next I'm just going to put the gradient of the differentiate function. So this is the graph minus 96x over 3x squared plus 1 all squared. And we can see when x is 1, dy by dx is minus 6. It's kind of like told us that, and if we put the tangent in as well, we can say, okay, well, it's definitely got a minus gradient because it's going that way. It's very steep, so I can quite believe that it's minus 6. You're not going to have this visual when you're doing questions very, very often, but sometimes, but it definitely helps me. It might help you just to see what's happening as you're going. And there's some questions for you to do. Enjoy.